given that most faculties or most of us in face-to-face class, we don't get the chance to cover it. So there are 3 PowerPoints in Newton covered. I would just, suggest you just go over the first one as the assignment for open book. Sure, look at the other just to be able to do the assignments, but for the exams, just the first PowerPoint would be enough. I can go over the PowerPoint with you at this point or answer any questions you might have, and let you watch the video from the YouTube, because I'm going to cover very similar parts of this chapter, just the how to name and how to count the number of ligands or the coordination number, and monodentate, bidentate ligands. So it's not a lot. Do you have any questions before we continue? Any questions that you might have? Questions? No questions? Okay. So do you want me to go over this PowerPoint, or you are going to watch the video from the YouTube? It's very similar. And when I found this PowerPoint also from the Alto useful, so I can go over this PowerPoint with you. Oh, the exam 5, which is based on chapters 8 and 9, which we covered last week. Yes, exam 5, which is based on chapter 8 and 9, we covered last week, and then it was set for today to be due at 11:30 p.m. So you use the next few days finishing up the unit 10, because 7th is the last day. You have 3 more days of the semester. Right, that should be the due date. This is the last class meeting, and if you still have any questions, you send me an email, and I will reply to your email. I will help you if you have any questions. And if you think we should have another meeting, I don't have problems. It's just that because we are done with the units, I think that you need the time to do your assignments. Okay. Do you have any questions? No questions? Okay. From the coordination chemistry, because that's basically related to the transition metals. Some of the transition metals, they can bind to covalently. They can bind to Lewis bases. That means they have pair of unshared electron or negative charge, and they can form bond with them. So transition metal would act as the central metal ion, as the transition metal, and then the Lewis bases, they are known as the ligand. So the ligands, they are loner atoms, with the lone pair, or they must have pair of unshared electrons. So the type of bonding is like, I'm sorry, the type of bonding is a coordinate covalent bond. The coordinate covalent bond means that one element provides pair of electrons and the other one, it just provides the empty orbital. So we can see this, the examples. So so this would be the transition metal. We have ammonia as being the two groups that is attached because ammonia has pair of unshared electron on nitrogen. So nitrogen forms bond using coordinate covalent bonding to silver. So ammonia in this case is known as ligand. And how many of those do we have? It's two. So in this case, it's known that coordination number, so that's one of the questions that you could get, how many groups are attached to the central metal atom, so, or ion, and in this case, you have two. So coordination number is two. You see, ammonia has no charge, has zero charge. Silver ion has one charge, Ag1 plus. So when you bring two ammonia, it doesn't affect the charge of the complex ion, and your complex ion ends up with 1 plus charge. If you had a ligand like a Cn minus, you bring that to form bond with the silver, this charge is going to change. So if you bring like two Cn minuses with 1 plus charge, the overall charge would change to negative. But what I'm saying, the ammonia, since it doesn't have any charges, it doesn't affect the charge of the silver. So the complex ion is going to have 1 plus charge, or ends up with the 1 plus charge. Some ligands, like diethyl, like this amine that we have, or diamine, ethyl and diamine, we have two nitrogens per molecule. If we have two nitrogen per molecule, that means that this can replace two ligands because it can form bond from two nitrogens to the central atom. So if you take any one of those, if you take any one of these groups, it forms two bonds. This is known like a bidentate. Bidentate ligands, they have two atoms that they can form coordinate bond with the metal ion in the center. So each one would count basically as two. So the coordination number for cobalt here is going to be 6 because we have 3 ethylene diamine. 3 ethylene diamine, each one forms 2, and then you end up with 6 altogether. So coordination number for cobalt is going to be 6 because you have 3 of these bidentate. Dentate comes like biting, so it can bite the central atom from two parts. So from 2 of the nitrogens that they have pair of unshared electron available to share coordinately with this cobalt. The charge of the cobalt before forming this complex ion was a 3 plus. We bring 6 bonds to cobalt, but none of them bring negative charge, so the 3 overall plus charge is going to stay. So that's called a bidentate. Number of ligand, it's called coordination number. So 3 bidentate, total of 6. We also have like a polydentate with the polydentate. That means you get more than one, or more than 2. If it's 2, would be bidentate. Polydentate, it would be would be more than 2 site that that group can attach to the central metal, like this group here. It can form bond with the iron from 4 different, so it's like a tetradentate, and it's known as the Schlieding ligand or Schlieding agent that basically surrounds the metal using more than 2 site. So in this case, it's like 4 of them, 4 site that is attached to the iron. You have monodentate, bidentate, and polydentate. What's the coordination number for cobalt in this case? Coordination number is going to be 6. And how do we know it's 6? Because there are 6 water molecules that is attached to cobalt. The hemoglobin, that's this molecule here, like very similar to this. And how many dentate you have here? It's 4, so it would be tetradentate, 4 nitrogen that can donate lone pair of electrons to them. Based on number of ligands that we have for the complex ion, we could have different shape of the molecule. For the complex ion, if we have 2 ligands, it would be linear, and for 3 ligands, it's going to be trigonal planar. And these are some of the examples. You see, you have here copper. The overall charge is a 2-. Where is that 2- coming from? If you have copper 1+, and then you have 3 Cn1-, if you bring the copper with 1+ and then add Cn, 3 Cns, 3 negative charge with one positive charge is going to overall charge of 2-. So when you see this, the charge outside of the bracket, that belongs to or it represents the overall charge, and overall charge means the charge of the ligands times the number of the ligands plus the charge of the metal ion. Otherwise, the metal ion doesn't have the charge of negative. Metals always, they have positive charge. So if you have here 4 Cls and then 2 is the overall negative charge, that means this nickel had a 2+ charge. So if you have 2+ charge and then you bring 4 Cls, when the ligand is just 1 or monoatomic, you don't have parentheses. So Cl4, so in ICl4, you have 4 negative charge coming from Cl, 2 positive charge from the nickel, and overall is going to be 2 negative charge. So as long as you understand the charges, that would be, so you know where the charges are coming from. You don't have to know all of these shapes. The ones that you need to know is the 2, 3, 4, and 6. Okay. 6 is going to be octahedral. If it's 2, is going to be linear. 3, trigonal planar. Very similar to the number of covalent, number of electron cloud. If you remember, if you had 2 electron cloud for VSR, you had linear shape. For 3 electron cloud was a trigonal planar. For 4 of them was tetrahedral. So in this case, you have 2 cases that you could have 4 ligands, or the coordination number could be 4. And then if there is a D0 or D10, and that comes from the electron configuration of transition metal, that's for low oxidation number state, you would get tetrahedral. For D8, you will get square planar. So the shape is going to be different, depends on the electron configuration of the central atom. And then for 6, you have octahedral. So make sure you just remember those 2, 3, 4, and 6. You don't have to memorize everything here. So what's the shape of this complex ion? In order to find the shape of the complex ion, you're going to count the ligands. You have 1, 2, 3, 4, 5, and 6. And because it's 6, the shape is going to be octahedral because you have 6 ligands. So it's going to be octahedral. So coordination number is 6. The charge for cobalt is 2+ because water doesn't have any charges. And you have 6 donors or 6 ligands, and the shape is going to be octahedral. For the for four ligands, when you have 4 ligands, you have the 2 examples here. For the D0 or D10 configuration is going to be tetrahedral, and for D8 it's going to be the square planar. So depends on the electron configuration of the central atom. It could have 2 different shape when you have 4 ligands. Geometry of this compound: iron is your metal atom, and then the complex ion is written in the bracket. How many ligands you have? You have 2 and 4 is 6 ligands. So if you have 6 ligands, it's going to be octahedral. And for this one, CuCN3, what's the shape? You have 3, coordination number is 3, and for 3 coordination number is going to be trigonal planar. So basically you count how many what's the coordination number, and you refer to that table in order to determine the shape of the molecule. To name the complex compound that is coming from coordination complex, that means your ion contains some ligands. If it's an ionic one, you're going to always name your cation first. So just like a metal, non-metal, you name the metal first and then the non-metal. To name the non-metal or the complex ion, you're going to name the ligands first and then the central ion or the central metal ion. The ligands, if you have same ligands, more than one, you would use di for 2, tri for 3, tetra for 4. And if you have different types of ligands, like the example we had water and ammonia, you are going to name your ligands based on in alphabetic order, and then you bring the name of the metal ion. So ligands should be named alphabetically. Okay. For naming of the ligands, for water, you don't say water, you would say aqua. And then for NH3, you are going to say amine. And for CO, you are going to use carbonyl. So you are using like bicarbonyl for 2, dicarbonyl for 2, tricarbonyl for 3 CO, or diamine or tetraamine for 2 or 4 ammonia. And if it's just 1, it would be aqua. If it's going to be 4, it's going to be tetra aqua. 2 of the same, 3 of the same ligand, 4 of the same ligand. So these are some of the examples. We have two types of you have one type of ligand, so bracket stops here. So that's not part of the ligand. So you have 6-ammonia. It's going to be hexaamine cobalt. Hexaamine cobalt chloride. Hexaamine cobalt chloride. Do you have to say, is it trichlorine? No, this is just like ionic compound. We know the charge of the cobalt is cobalt 3. So you have to say that it's a cobalt 3. Ammonia doesn't bring any charge, so the overall charge for the complex ion is going to be 3+. We do need 3 chlorine to cancel that 3+ charges. Platinum, in this case, you have the platinum. What's the charge of platinum here? How do we know the charge of platinum? So you look at the charges for your ligands. Chlorine has charge of -1. You have 2 chlorine, so it's going to be 2-. And then the overall is 2+. So if the charge for platinum is X plus the 2- equals 2+. So what should be the X? X is going to be +4. So when you are naming, you have to use the Roman numeral for 4 to show the charge for platinum. We don't start with the platinum first, we start with the ligands, but I just wanted to make sure you know how to calculate the charge for the metal ion, because you have to indicate transition metals, they have variable charges, so you have to say what charge is used in this case, in this complex. That's how you calculate the charge. The charges inside, if you add them all up, it should equal the charge outside of the bracket. Like in this case, it would have been like a 3+, because now 3- chlorine is canceling the charge of the 3+. So the cobalt is going to be 3+. Platinum here must be 4+, because 2- coming from chlorine, 0 charge is coming from ammonia, and the overall charge is a 2+. So the name for this compound now is, we have 4 amine group, so it's going to be tetraamine, and then 2 chlorine, so it's going to be dichloro. You see, chloro as a ligand is named as chloro, but as the ion is named as chloride. So when it's inside the bracket is known as chloro. Outside of the bracket is chloride. So tetraamine dichloro, platinum 4 ion. Silver, the charge for silver is a +1 because ammonia doesn't bring any charge. So we have a diamine silver 1 in parentheses, and this is ion, so you have to say this is ion. If it's not an ion, this is a compound. That means the overall charge of the compound is 0. You have chromium here. This is chloride. Okay, this is chloride. This is a chloro. Inside the bracket is chloro. Outside of the bracket is chloride. Chromium. What's the charge of chromium? The outside of the bracket, or the overall charge for the bracket, would have been a +1, because we bring 1 negative charge from chlorine to cancel that charge. And then what would be the charge of chromium? That with 2- is going to be 1+ overall, so this must be 3+, and you bring the 2- from the chlorine. 3+ plus the 2- is +1. So the charge for chromium is a 3+. That's what we are interested in when we are naming, because that should be included in the charge of the chromium when we are naming. Okay, tetra. So this would be tetra aqua dichloro chromium 3 chloride. Okay. So this, all the questions here from now on is you have the question and the answers. I'm sure you can read. I just want to make sure that you know how to count the number of ligands, how to find the charge for the metal ion, and to get the difference between the ions that are inside the bracket, outside the bracket. Like if you have halogen inside the bracket, it's going to be chlorobromo, but outside of the bracket is going to be chloride or bromide. Okay, and please follow these examples. They cover everything with the question and answers. Please follow them, and if you have any questions, you're going to email me your questions later. On Thursday, I'm going to log in for question and answers. There's really no new material, but for question and answers, if there was any questions, you can please ask me then. Any last minute question right now? Any questions you might have now? Okay. Okay, perfect. Thank you so much and have a great day. I'm gonna stay around. I'm just gonna, wait if someone joins and ask any questions. But I'm not bringing anything new today. The PowerPoints that I posted, they can help you from YouTube, and this introduction, just being able to count those is going to help you with the following up with the examples that you have the answers already. Sometimes you have the question, you have the answer, but it's not very clear. But I was hoping that with these examples that I had, at least it makes it easy for you to follow. I am looking for a workshop that I logged in. Thank you so much. Friday office hours. What day is Friday? Is it 7th? Sure, I will Friday office hours too. Just for questions and answers in case of any. Thank you. You have a nice day too. Have a great day. I'm going to stop recording, but I'm not logging out yet, just in case if you have any questions, but I will stop the recording.